Okay, let's look at 1.6 day 2. I need to start off with number 16. So for number 16, it says solve. And so I've got 3. 16, I've got 3. Absolute x plus 1 minus 4 equals 5. So I add 4. And then I divide by 3. Now the important part is, now that I have it as the absolute value of something equals a number, then I can change its form. If the size of something is 3, then that thing was equal to -3, or that thing was equal to a +3. One of those two things happened. So that means your number was either -4 or your number was 2. Those are two possible answers. Number 20. For number 20, if the absolute value of 3x minus 2 is equal to 7, then if the size of your thing is 7, then either you were equal to 7 or you were equal to -7. So that means we either get 3 or we get -5/3. Then for 21, I'll just do it down here. So for 21, we have the absolute value of 3x minus 2 is equal to -7. But notice, how can the absolute value ever be negative? It can't. If you say your size is negative, I say there is no solution. There's no way I could put an x value in here, take its absolute value, and get a negative. So then we go on to 26. So 26 says, find the x and y intercepts. So the x-intercepts and the y-intercepts for the following graph, 26 and 28. So for 26, it's 4x minus 3 plus 4. And so the x-intercept is where y equals 0. So I simply set all my y's equal to 0. And now I solve. So I guess you get a -4. Absolute x minus 3. So the absolute x minus 3 is equal to -1. When can you take the absolute value and get a negative? You can't. So there is no solution. That means there is no x-intercept, which makes sense because it's an absolute value that you've shifted 4 up. So it's going to look something like this. So of course, it's not going to hit y equals 0. Then the y-intercept is where x equals 0. So for x equals 0, I just take my equation and plug in 0. So I get the absolute value of -3, which is 3. So I get 4 times 3 plus 4, which is 12 plus 4, or 16. So that means the y-intercept is 0, 16. All right, that was number 26. If I go on to 28, so 28, take the x-intercept and the y-intercept. Again, the x-intercept is where y equals 0, so I set my entire y, which is this, equal to 0 and solve. So we get -6, but then if I divide by -2, I get a 3. So then if the size of my thing is 3, I can rewrite it because I know that thing is 3, or that thing must have been -3. So that's where you get -4 is one answer, and 2 is another answer. So 2, 0, and -4, 0 are our x-intercepts. I know my y-intercept is where x equals 0, so I simply take my function and plug in 0 in for x. So from there, I get -2 times absolute 1, which is just -2 plus 6, or 4. So that means 0, 4 is my y-intercept. Great, moving on to 32. So for 32, its absolute x minus 4 is greater than or equal to 8. So I need to solve it. So if my size is greater than or equal to 8, then that means that you must have either been greater than or equal to 8, or you must have been less than or equal to -8. So that means you were either greater than 12 or you were less than or equal to 4. So that means you are either 4 or smaller, unioned with 12 or bigger. I guess usually the way that we'd write that is like so, with a union in between them. Cool. All right, that's 32. If that's 32, next is 34. And so 34 says, let me do it on the next one. Let me go over. So 34 says absolute 3x minus 5, again, is greater than or equal to negative 13. So if my size is greater than or equal to negative 13, then I must have been, make sure I did that right. Yes. I must have been less than, well, actually, just stop for a second. Stop for a second. We want to delay procedures for just 1 second. I took an absolute value. It's always a positive number, right? When is a positive ever greater than or equal to negative 13? That would be always. This is always greater than or equal to negative 13. A way to show you that is if you graph 3x minus 5, the absolute value, you are going to get something that's moved over here and that opens up, where when you go over 1, you go up 1. So it looks something like that. And you're asking, when is that bigger than negative 13? It is always bigger than negative 13. So on a high stakes assessment, this is really what you'd have to put. So that's 34. Let's look at 48. So 48, if I'm looking at 48, it's asking you to graph by hand. So 48 is 2x minus 4 minus 3. It's not quite in the right form yet. On these, I like to see A, absolute B, x minus h plus k, where this tells us our left-right shift. This is our up-down. This is our vertical stretch or compress, and B is our horizontal, horizontal stretch or compress. So I'm going to rewrite it first by factoring out a 2, and so you get this. And so I think my original graph is absolute x, that's my parent function. And so on that graph I'd have many points, but I think you know I'd have those two. So then if I work from the inside out, then what you end up getting is, first I shift it to the right 2. So I'm going to have, this would mean 2, 0, and 3, 1 are on my graph. And then if I take that and do this to it, that is a horizontal compression. So then if I draw this graph, that is a horizontal compression by a factor of a half. So that means I multiply all my x values by 1/2. So it's going to be this, which just gives me 1, 0, and 3/2, 1. But then at the very end, this moves me down 3. So if I have my final graph, which is this, minus 3, move down 3, it's going to be this, and it's going to be this, are 2 points on that graph. So really showing what it looked like, I first moved it to the right 2. So here's my original. To do a quick sketch, I moved it to the right 2. So over here at 2. And then I did a horizontal compression by a factor of a half. So it did boop, boop. So it did that. Trust me, it's straight. And then it moved it down 3. So then it moved it down here, towards down at a negative 3 for my 0, 0. Pretty cool, yeah. But remember, what it did is that horizontal compression took everything, and when it compressed it, moved it over here to 1 really when it compressed it also. Okay. All right. I would need to see this and a little quick sketch. So that's 48. If we look at 50, it's the same sort of deal, graphing it by hand. So for 50, if I have this, what's going on? I think first I went right 1, and then this is a reflection across the x-axis, and then this is down 3. So if I have my original points, which there are many, but I like these two, and then if I do this first, because I'm working from the outside in, it moves me right 1, so I'm going to be here. And then if I reflect across the x-axis, let's see, if I reflect across the x-axis, all my y's are going to become negative, so it does this. But negative 0 is still 0. And the last thing, if I move down 3, it's going to be this with a negative 3. It's going to be this with a negative 4. So let me go ahead and make this green, just so it's easy to see. So if my original thing looks like this, if that's absolute x, then when I move it to the right one, maybe it looks like this. That's x minus 1 because I moved to the right one. And then I reflect it across the y-axis. That's going to be this. It's going to be negative absolute x minus 1. And then if I take that picture and copy it and then paste it down 3, it look like this. And that's what negative x minus 1 minus 3 would look like. It would be this one right here. Cool. And that, my friends, is number 50. 50. Okay, let's move on to 57. This is a great example of delaying procedures. So delay procedures. Don't jump right into a procedure without actually thinking about what you're working with. So notice what it says. It says that you take the absolute value of stuff, which is going to be positive, plus 3 is greater than negative 1. Well, do you agree that a positive number plus positive is still positive? So all this is still positive. When is that ever greater than negative 1? Well, it's always true. So this is always true. So for any x value, this thing is always true. Okay, so that was ridiculously easy. So that's 57. Once you saw it in the right way, right? Okay, true proportion of people who give a favorable rating to Congress is 8%, right? With a margin of error of plus or minus 1.5. Describe it in absolute value. Then our proportion, P, so we're going to make it P, minus 8% is in a margin of error less than or equal to 1.5 on either side. So that means that this thing, so this is your answer. But just to make sure we understand it, if this thing is jammed in between 1.5 and negative 1.5, then P is jammed in between 8 plus 1.5 and P minus 1.5. I'm sorry, 8 minus 1.5. So that means P is jammed in between 9.5 and what, 6.5? Again, your answer to this question just has to write it in absolute value, and that's it, but hopefully this helps you to understand it a little bit more. 61, last question of the day. Thank goodness, because I want to eat my lunch. Is 64. Tolerance for a ball bearing is 0.1. if the true diameter is 2 inches and the measured value is x inches, express the tolerance using absolute value. So here's what I measured. Its distance away from 2 better be less than or equal to